Hello everyone! In this video you will learn about two families of clustering methods, namely centroid clustering and density clustering. Together we will see how clustering can be performed to obtain clusters based on centroids and density. After watching this video, you will be able to explain the technique of centroid-based clustering and density-based clustering. There are mainly four families of clustering methods. There are centroid-based clustering based on centroid, density, distribution, and connectivity. This video will cover the first two families. First, let's find out what is centroid clustering. From the name, you might already know that centroid clustering is a family of clustering methods performed based on centroids. We define centroids as a representative sample of the cluster. Here we assume the number of clusters is given. There are two principal steps in centroid clustering methods. The first one is to update centroids, and the second is assigning samples to a cluster with the nearest centroid. Let's take a look at the plot on the right. In the first iteration, we start with two random centroids in the feature space, the red and blue samples indicated by a circle. Next, we assign samples to the nearest centroid to form a cluster. The line that you see over there represents the division of regions from which data samples in one region are closer to the red centroid, and the other region on the right is closer to the blue centroid. Then we assign the data samples to the nearest centroid, so they all change colors in this plot. On the left of the feature space, the data samples are now red and the samples on the right are in blue. In the next step, we go back to step 1 and update the centroids. For instance, we use the mean value of the clusters as new centroids, as you see how the red and blue centroids change their position in the feature space. Next, in the next step, we repeat again by assigning data samples to the nearest centroids. We define the new regions, and now you see that there are 3 red samples that are belonging to the blue centroid. Here we update again the color of samples based on the new assignment. Moving forward, we need to update again the centroids. Centroid clustering has an iterative approach, so we repeat step 1 and 2 again and again until there are no changes in the samples of the two clusters. This means the centroids and clusters are both fixed at the end of the iteration. Next, let's learn about density clustering methods. The idea of density clustering is to group samples based on how close or similar they are to each other. If the distribution of samples in the feature space is dense, it is likely the samples will belong to the same cluster. We need to define parameters for density clustering. An important parameter is a minimum distance between data samples. We will see how density clustering is performed based on the distance d. There are two principal steps for density clustering. The step 1 is to select a random sample that does not belong to a cluster, and in the step 2 is to check if other samples are within the predetermined distance d. If yes, the samples will be grouped into the same cluster. In the feature space on the right of the slide, let's pick these blue samples as an example to start with step 1. The next step is to see if other points are within the distance d from the selected sample. Here, note that if we use a distance d that is too short, it will lead to 14 different clusters, because each data sample will belong to its own cluster. So one cluster, one datum. So let's increase a bit this distance. Then in step 2, we check if there are other samples within the distance d. In this case, there are 2 other samples nearby as shown in the plot. Next, for those 2 new samples, we check again if there are data points nearby within the distance d. In this case, there are not, so we stop. And we have determined the first cluster shown as blue samples. Once we have found a cluster, We repeat again step 1. Here, we select a random point that does not belong to a cluster yet, which is in this case the yellow sample in the plot. Again, we go to step 2 and check for a distance d whether there are other samples nearby. In this case, yes, there is one more sample within this distance. Now we do the same to check if new sample has nearby samples, and eventually we have found a new cluster with 4 samples in yellow. You see, by repeating the 2 steps, we will find out that we have one more cluster shown by red samples in the plot. In the end, density clustering stops when there is no sample that doesn't belong to a cluster after the iterations. We can observe that the number of clusters is a consequence of a distance d, the parameter d. In this video, we first learned how centroid clustering is performed based on centroids. 2 principal steps: updating centroids and assigning samples, and iterate till centroid clustering finds the optimal centroids and clusters. In the iterative process, we know that centroids determine regions in the feature space where the cluster of samples are also determined. Then we learned that density clustering is performed based on a given distance between data samples. 2 principal steps for density clustering: iterates till all samples find their clusters. The number of clusters is determined when the iteration stops. It is actually equal to the number of iterations needed.